Hello students, in this video we will discuss some more numericals on limits using trigonometric functions. The main formulas that we are going to use are limit theta tends to 0 sine theta upon theta equals to 1. Second formula is limit theta tends to 0 tan of theta upon theta is equal to 1, and the third one is cos of theta is equal to 1. So here during numericals you have to see that we have same angle here, here as well as here. So we have to match all these. If theta tends to 0, then we have sine of theta divided by theta. Then we can put the value of this limit is equal to 1. Let us solve some numericals. And the first numerical is limit x tends to 0 tan of 2x divided by x. So as you see, we have written the formula. I told you we have to match all these three values. So we can easily multiply by 2 here and 2 here. And also as x tends to 0, this implies 2x also tends to 0. So using this basics, so we put the above limit can be written as limit 2x tends to 0 tan of 2x divided by 2x. And we know scalar can be written outside 2 into this. So which further is equal to, as from the formula, this is equal to 1. And the answer is 2. Let us solve next numerical, that is limit x tends to 0 sine ax plus bx upon ax plus sine bx. So here you see, so we have sine ax plus bx, ax plus sine bx. So we cannot apply any formula directly. And also we are given that a, b as well as a plus b all are non-zero. Now very smartly we have to perform the calculation part here. So here we can write limit x tends to 0 sine ax plus bx. We divide by x here and we multiply by x here. This may be written as ax plus sine bx, or very easily we can separate this into two parts, this by x as well as this by x. So let us see what it becomes. So as you see, this becomes sine ax upon x plus this x cancels. So we write this in bracket, and similarly here, how can we write this as? We take this x in the denominator of this. So I think you will easily get this step, bx upon x. And similar calculation operation we will perform here. So we can write it as taking limit inside, limit x tends to 0 sine ax upon x plus b. And as you see, limit of a constant is constant, so we write b here. And taking limit here, so it becomes, and also separating it into two parts, limit x tends to 0 of a, limit x tends to 0 of sine bx upon x. So very easily we can multiply by a here and a here. And also if x tends to 0, ax also tends to 0. And similarly here we multiply by b here as well as here. And also if x tends to 0, bx tends to 0. Now what it becomes, let us write it here. So it becomes limit ax tends to 0 sine ax upon ax, and this a can be written outside, plus b into 1 upon, this is limit of, this is a, plus b times limit bx tends to 0 sine bx upon bx. Now very easily, how much is this? 1. And how much is this? 1. So we are left with a plus b here and a plus b here, which very easily cancel out, and answer is 1. Next numerical is limit x tends to 0 sine 4x upon sine 5x. So here very easily we can convert this into the desired form. For that, what we have to do, we have to multiply by x and divide by x into x upon sine 5x. Or this can be written as limit, so we multiply by 4 and divide by 4, and here we multiply by 5 and divide by 5. So the constants can be written outside. 4 by 5, limit x tends to 0 sine 4x upon 4x, as well as limit x tends to 0 sine 5x by 5x. So as earlier, if x tends to 0, 4x will also tends to 0 and 5x will also tends to 0. So we easily write 4x here and 5x here. So putting the formula, this is 1 as well as this is 1. So we are left with 4 by 5 into 1, 1 by 1. 4 by 5 is the desired answer. Let us solve one more numerical. Limit x tends to 0 under the root 1 plus x 1 minus x upon sine of x. So as earlier, we know that we can easily remove this under root by rationalization. Let's do that. So with what we rationalize? With the same term but with opposite sign. 1 plus x plus 1 minus x divided by 1 plus x plus 1 minus x. So as you see, this is a minus b, a plus b. So it becomes a square minus b square, and with that square root will cancel out. So we are left with 1 plus x minus 1 minus x. I hope you got it, that square root cancel with the square, and the denominator we have sine x into 1 plus x 1 minus x, and here 1 will cancel out, and this further is equal to limit x tends to 0, 2x upon sine x into 1 upon 1 plus x, 1 minus x. Or further, 2 can be written outside of the limit. Limit x tends to 0. So this may be written as x upon sine x into limit x tends to 0 under root 1 plus x, 1 minus x. So as earlier, very easily we can write it as 1 upon limit x tends to 0 sine x upon x, and we put x 0 here, under root 1 plus 0, 1 minus 0. So which further imply 2 into 1 upon 1 into 1 upon 1 plus 1. That is 2 into 1 by 2, and we are left with 1. Desired answer. So I hope you got all the steps. Okay, let us move further and solve another numerical. That is limit theta tends to 0, 1 minus cos theta upon theta square. So we are getting theta square in the denominator. Can we have any formula so that we have square term here? Yes, very easily we can convert this into square. We all know that 1 minus cos theta is equal to 2 sine square theta by 2. So using that formula here, this becomes limit theta tends to 0, 2 sine square theta by 2 upon theta square. So can we make this theta by 2? Yes, we divide it by 4 and multiply it by 4. So it becomes, 2 cancel with this 4, 1 by 2 is outside the limit. Limit theta tends to 0 sine theta by 2 upon theta by 2 whole square. I hope you got this step. We have square here as well as theta by 2 square here. So we can easily write whole square of this. And also if theta tends to 0, theta by 2 also tends to 0. So using that here, so we have 1 by 2 limit theta by 2 tends to 0 sine theta by 2 upon theta by 2 square, and the value of this is 1. So we get by 2, 1 square, 1 by 2 is the required answer. Okay, let us solve another numerical. That is limit x tends to 0, x tan of 4x upon 1 minus cos 4x. So as you see, we have trigonometric functions. So here again, we convert this into sine. So what is the formula for that? That is 2 sine square half of this angle, that is 2x. Let us put that value here. So it becomes limit x tends to 0, x tan 4x upon 2 sine square 2x, which may further be written as limit x tends to 0, this is x upon sine square 2x, and here we have tan of 4x. So we very easily we can multiply by x here and divide by x here. I hope you got this step. and also we want 2x here. For that, we multiply by 4 here and divide by 4 here. Again, we need 4 here, we multiply by 4 here and divide by 4 here. So as you see, we already have this 1 by 2, we also write it here 1 by 2. Okay, so let us see what we are left with. Actually, this 4 will cancel out. We are left with 1 by 2 only. Let us write 1 by 2 outside the bracket and let us distribute the limit. X tends to 0. Here this is 2x upon sine 2x whole square, and also limit x tends to 0 tan of 4x upon 4x. So as again, if x tends to 0, 2x will tend to 0. If x tends to 0, 4x will tend to 0. So how much is the value of this? 1. Also this is 1. So we are left with 1 by 2 into 1 square into 1. That is 1 by 2. Answer. Okay, let us solve one more numerical. That is limit 1 minus tan x upon x minus pi by 4. So this is a little bit different type of question. So here, as you see, we cannot apply any formula directly. It is better to break tan into sine by cos. Let us do that. Limit x tends to pi by 4. So we can write 1 minus sine x upon cos x divided by x minus pi by 4. And take LCM here. So very easily this may be written as x tends to pi by 4 cos x minus sin x upon x minus pi by 4 into 1 by cos x, which is the LCM actually, denominator part. And as you see, can we convert this into sine A minus B? What is the formula for that? We all know sine A plus B, A minus B is sine A cos B minus cos A sine B. So as you see, we want x minus pi by 4. And how we get pi by 4? If we divide by under root 2 and multiply by under root 2. You see, very easily. And what is 1 by under root 2? This is cos pi by 4 as well as sin pi by 4. Let us write what we have done here. X tends to pi by 4. This is sin pi by 4 cos x cos pi by 4 sin x divided by x minus pi by 4 1 by cos x. So very easily this may be written as under root 2 into limit x tends to pi by 4. This is sine pi by 4 minus x divided by x minus pi by 4 1 by cos x. So as you see, we have x minus pi by 4 and sine is a odd function. We can change the sign here, and sine of, we know sine of minus theta is minus sine theta. So minus will be written outside. And also if x tends to pi by 4, so x minus pi by 4 will tend to 0. So what this becomes? This becomes under the root to limit x minus pi by 4 tends to 0 sine x minus pi by 4. So we have taken minus outside. Let me write minus here. Divide by x minus pi by 4. And also limit x tends to pi by 4 1 by cos of x. So very easily, how much is this? 1. And here we put cos pi by 4. And we have minus root 2 into 1 by cos pi by 4. And cos pi by 4 is 1 by root 2. And root 2 will take reciprocal here. And we multiply these two. We get minus 2 as answer. So I hope you all got an idea how we can find limit of trigonometric functions.